Hello everyone, my name is Shari and I am a digitization professional at the August-Wilhelm Scheer Institut. The August-Wilhelm Scheer Institut is a research institute in Germany that is doing research in the topic of digitalization. Inside the institute there are different research groups that focuses on different fields of application, like for example digital health, digital new work or smart energy. And the paper I will present to you today is a part of the research project of the Smart Energy Lab called FlexChain. FlexChain is about developing an intelligent trading platform for small prosumer flexibility potentials in the low voltage grid, with which the local grid can get stabilized. And the paper I will present you today is about the design of this trading platform. So, as I mentioned before, the presented paper is part of the research project FlexChain. And FlexChain is a funded project. It is funded by the German Federal Ministry of Economic Affairs and Climate Action and has started in October 2020. The motivation for the project results from the increasing loads in the low voltage grid due to, for example, electric vehicles or heat pumps. And this means, of course, a higher use of capacity in the distribution grids. Paired with the increasing volatility in the energy grids due to the energy transition, there is an increasing risk of grid congestion in the low voltage grids. And FlexChain now wants to develop a tool for the DSOs, so the distribution system operators, that they can solve this local grid congestions with the flexibility potentials of the households. And this flexibility potential of the households arises from potential load shifts, in the dimension of time and quantity inside the households. The assets we consider in FlexChain for this flexibility provision of the households are electric vehicles, heat pumps, photovoltaic systems, and energy storage systems. So to sum up again, FlexChain is a tool for DSOs to stabilize their low voltage grid with flexibility potentials of private households. And to realize the energy market, the FlexChain project aims to use the blockchain technology, and this in an economic efficiency way. How the market is designed in detail, I will show you on the next slide. So let us take a deeper view at the energy market we designed. It begins with the DSO who simulates his grid and sees that there is a local grid congestion expected. If this happens, he can put in flexibility request on the energy market platform in FlexChain. To do this, he needs to set some matching parameters. For example, he sets the price he is willing to pay for the flexibility, or also which households can potentially solve the local grid congestion at all, and therefore are entitled to offer flexibilities for the request of the DSO. And especially the latter pays on the first objective listed at the right side of the slide. The objective of the FlexChain energy market to stabilize the grid locally. The second objective, which should be achieved with the energy market design in FlexChain, is the high automation of the flexibility trade. The high automation of the flexibility trade is achieved on the side of the households through to the use of a home energy management system called HEMS. These HEMS is able to determine and activate the flexibility potentials of a household and can calculate the offers for the flexibility trade. So it is doing the main tasks of the participating households so that there are as few manual tasks as possible needed to be done by the occupant of the household. After the HEMS of the households sends the flexibility offer to the market platform, matching can take place and the market results can get communicated to the participants. To ensure a high confidentiality in the FlexChain market, hashes of the market result are generated and put on a blockchain. These hashes contain the flexibility request and all sent offers to this flexibility request so that the participants can check if everything was done in a right way. So the design of the market in this way, I mean to let the computationally intensive matching process run on, I would say, a classic, cheaper infrastructure and use the more expensive blockchain technology for storing the market results in a hash, increases on the one hand the trust in the market and on the other hand keeps the transaction costs as low as possible. The goal of this explained market design is to achieve the last two objectives regarding the design of the trading platform listed on the right side, namely trust and economic efficiency. But of course, there are other options the market can be designed in terms of the blockchain use, which we also investigate during the FlexChain project. The three main options are shown on the next slide, with their respective impact on the achievement of the objectives in terms of trust and economic efficiency. So as explained before, we're currently focusing on the option in the middle, so that the entire market mechanism is not mapped on the blockchain, but a hash of the matching result is stored on the blockchain. The computationally intensive matching processes take place on a classic infrastructure, for example, a virtual machine, and so that the transaction costs can get reduced. But also trust is generated in this option due to the stored market result inside the hash at the blockchain. Another option would be to put everything on the blockchain, so also the computational intensive matching algorithm. This option is shown at the left. The security and the confidentiality will be high in this option, but also where the blockchain induced transaction costs. So in this option, the generated transaction costs would be in no proportion of the low economic value of the traded flexibility, which is because of the small scale of the flexibility very low. The third option would be to run everything on a classic infrastructure, but then the benefits of the blockchain regarding the security and the confidentiality couldn't get used. So every three options could in principle get used for running the FlexChain energy market, but in the end, the question is until when the price of safety is in proportion to the economic efficiency of the trade. In our hybrid approach shown here in the middle, we try to link the economic efficiency and the confidence. Finally, however, the research question of how economically efficient trading in a blockchain-based energy market can take place must be answered at the end of the project, when also the planned field test, I will show you at the next slide, has been completed. This field test is planned for the beginning of 2023 in Saarbrücken, which is a mid-sized city in southwest Germany. In the field test, 5 to 10 households will take part, which have flexibility assets like energy storage, PV systems, wall boxes and heat pumps, and HEMS so that they can participate in the FlexChain trading platform. To make sure that there will be some expected grid congestions in the low voltage grid of Saarbrücken to which the DSOs need to react, we will synthetically reduce the grid capacity through a scaling factor. So the field test is planned for 6 months, and in this time we will scrutinize the IT infrastructure of FlexChain, fine-tune the market parameters, and finally answering the research questions about the economic efficiency of a blockchain-based energy market. Thank you for your attention.